Okay, so we start first when we're doing force problems by drawing your free body diagram. All right, so we have our system here. F sub g. What's our upward force? What would that be called?
Tension.
I'd say tension. Okay, because we're dealing with an elevator here, so it's not sitting on something, it's not resting on something, it's suspended by this cable, okay? And we have values for both of these forces. Okay, what are the values for the tension force? 12,000 newtons, and our value for the gravitational force is 10,000. Okay, so if we want to find the net force, are we going to deal with net horizontal force or net vertical force?
No, sorry, vertical.
Probably vertical.
I was thinking horizontal.
All right, so we're going to take our F net, we take our up forces minus our down forces. So we'd be Ft minus Fg, which would then equal 12,000 minus 10,000. And that gives us 2,000 newtons in what direction? Up. The up force is bigger than the down force.
Oh, crap. So if it was going down, then it'd be negative?
Mm-hmm.
Okay.
Yeah, if it's a downward force, you can indicate it with a negative or you can indicate it with an arrow pointing down. That's up to you. Okay, so that negative indicates the direction for us. Questions here? This was easy. Just a little warm up for you. Okay. Suppose the only horizontal forces on a pumpkin that weighs 120 newtons are 36 newtons right and 52 newtons left. Draw the free body diagram to show all four forces and the net force acting on the object. So here's our system. It says this pumpkin has four forces. What are they? Okay. A little more technical name for them would be force of gravity. Yep, force of the table or force normal. And then we have some applied force to the right. We can just call F right because we have two applied forces here. We have some applied force to the left. Okay, according to the values given for these left and right forces, which of these arrows should be longer than the other? The leftward force should be longer than the other. So I need to make my rightward force a little shorter. We want to find net force acting on the pumpkin. Are we going to be finding net horizontal force or net vertical force? Horizontal, because the pumpkin's not moving up and down. It's not being lifted. Okay, so that means we know the normal force has to equal the gravitational force. So we're not concerned about that. We're concerned with horizontal force. So F net equals our right forces minus our left. So force right minus force left. F net would then equal 36 minus 52. Which would make our net force, what? 16 newtons to the left. And you could label that as negative 16 newtons if you choose. Okay? That negative indicates our direction. The negative gives us a direction. So if it's negative, we know that it's going left.
Can we write 16 newtons left?
Yep.
Do we have to do the
No, you could choose to do you could write it if you want.
Yeah.
All right, any questions?
120 newtons right to the pumpkin.
Mm-hmm. All right. Okay, two horizontal forces act on an object. One is 10 newtons west, while the other is 20 newtons at 30 degrees north of east. Calculate the net force. Ooh. Okay, so we just draw our free body diagram. This is no big deal. NBD. Okay, One is 10 newtons west, so we're going this direction. And the other is 20 newtons at 30 degrees north of east. Okay, so all we do is draw like this. So it's 20 at 30 degrees north of east. So that means our angle has to go in this little pocket since it says it's north of east. Okay.
So you go northeast.
North of east. That means north of east. Okay, so we go east, then we go north, and we work backwards and say north of east. So that means our 30 degrees has to go in this little angle right here. Okay. So here's the thing. Can we work with net forces that are at an angle? No. We need to find components of this force so that we can work with them. So we'll call this, what do you guys want to call this 20 Newton force? You can pick, what do you want to call it? F what? Applied or F pull or FP? Okay, let's say FP for F pull. Okay, so the 20 Newton force, we're going to call that FP for a pulling force here. We're also missing two forces on our regular diagram here. Actually, we don't need to include the normal force because it doesn't say anything about that. We'll just leave it where we are, okay? So this force pull, we can't deal with it at an angle, so we need to break it down into components. So this side would then be called force pull Y. This would be force pull X. Okay, we're breaking it down into components just like we've practiced the last day and a half. So we need to find these components then. F sub Py and F sub Px. Okay, so FPY, if I abbreviate it here like I have been, it's 20 times sine of 30. And we get 10. So 10 newtons. If we solve for x, we're going to take 20 times cosine of 30. Good. And we get 17.3. Okay. So now if we redraw our free body diagram with these components broken up, this is what it would look like. We'd have 10 newtons this way. We would have our y right here, FPY, is it going up or down? Up. So we have 10 newtons this way. And our x component, is it positive or negative? Positive. So we'd have 17.3 newtons going in this direction. The 20 we're done with now. We found the components of it, so we can't work with the 20 because it's at an angle. We have to find components, and then we can work with those. Okay? So we're done with the 20 for now. Yeah, Evan?
So, did you really do this all for y?
Yes, because we're going to take an overall net force and build like our new triangle. Okay? What's that mean?
How do you know that the 17.3 is going
Because it's positive. And it's part of this triangle, and this triangle goes east and north. So that means its components must then go east and north.
Would it be north of east or east of?
Wait, right here?
Yeah, okay, there would be east.
It was north of east for this
North of
one.
East, okay.
Okay? So now we have our new forces. Now we need to break it down and find our overall net force. So this object is going to be pulled at an angle again. We don't know what angle. We're trying to figure out where it's going to end up. Because right now we have something pulling at it at an angle in this way and something pulling at an angle from this way. So it's going to end up somewhere in between those two. We've got to figure out where. Okay, so we are going to take our net horizontal force here and solve for our net horizontal force, which will be right minus left, so 17.3 minus 10. And we get 7.3. That's our net horizontal force. Overall, it's going to end up 7.3 newtons in that direction. What about our net vertical force? Yeah, it's just 10. Okay, 10 newtons up is going to be our net vertical force. Okay, so now we draw our new triangle because we have our components here. I'm going to do this kind of over on the side. Okay, we have our new components of our triangle. We need to go 7.3 to the right. We need to go 10 up.
Would you take into account gravity on this one or no?
No, we're not really concerned with that. Just for this one. Yeah, for some we will. Uh-huh. Okay, so all we do now is find our resultant. And we find this angle, and that's our overall net force. Okay, 12.4 newtons at what? We're trying to find this angle right here. Okay, so if you're looking at this angle, the opposite side is 10. This side right beside it is 7.3. Because this was our starting point, this was our origin. So we had to go here and then here to get to our resultant point. So we made our new triangle. We just started we picked an origin right here. We went 7.3 to the right and 10 up. So we want to find an angle from our origin. 36.1 degrees what? North. Yeah, exactly. Second tangent to find that angle. Good. Okay, so we use Pythagorean theorem to find the 12.4, and then we use second tangent to find the degree. Opposite over adjacent. It should have been 10 over 7.3. Okay. Okay. So we need to do opposite over adjacent, which is 10 over 7.3. So you got what, Jennifer? 53.9 degrees.
Yeah, that's right. Yeah.
So, yeah, okay, moving on. Someone in a canoe paddles with a force of 200 newtons east, and the current exerts a force of 100 newtons at 45 degrees south of east. Calculate the net horizontal force. Okay, so what we did last time was the net overall force. Here we're just looking at net horizontal force, which means what component are we really concerned with? We're concerned with this east one, and then we're concerned with the horizontal component of this force. Okay, so let's draw our free body diagram here. East is the positive direction. Okay, so this would be 200. And we also have a force at 45 degrees this way, and it's 100 newtons. Okay, you can draw this component triangle on either side since it's a 45-degree angle. Okay, I'm going to move my 100 out of the way here. And we know this angle is 45 degrees. Okay, could everyone have done that by themselves, that diagram? I think you could. I hope you can. Okay, so we need to break these down into components. Okay, we can call this, we'll just call this first one force 1, and we'll call the second one force 2. All right, so we're not getting confused here. What would be my next subscript for this force? F sub 2, x. Very good. And then this would be F sub 2, y. Very good. Okay. Since we're only concerned with the horizontal force of this vector, what do we need to find then?
The
x. Yeah, we need to find overall x. We are only concerned with f sub 2x. We don't even really need to worry about f sub 2y. Okay, for this problem, since it's asking for net horizontal force, we're really only working with the horizontals here.
What about the S
Do you have a question?
I was talking about the one at the top.
Yeah, we will have to worry about that one.
Oh, okay.
Okay? But for our f sub 2, the only component that we really care about is the x, okay? So for f sub 2x, to find that, we take sine or cosine? Good. So sine of 45 equals f sub 2x over 100. I'm going to take 100 times sine 45. 70.7. Yeah? Okay. 70.7. And is that going in the positive direction or the negative direction? Positive, okay? So if I redraw my free body diagram here, okay, let's just say I redraw it. I have 200 newtons that's going for me, which is force sub 1. And then I also have this f sub 2x that's adding on to that. So f sub 2x, I can say it up here, and I just calculated that it's 70.7. Okay? And then if I was really concerned about the f sub 2y, I'd put it right here. That's the components of that angled vector broken down and added to our free body diagram. Right here. Okay? That's why we break them down into components, is to add them to our free body diagram. So what?
All you have to do is add those numbers together.
Yep, so we're going to find our net force. F net horizontal is going to be all of our rightward forces minus our left. Remember, right minus left. So we're going to take f sub 1 plus f sub 2x. Do we have anything on the left that we need to subtract? No. So you can either say subtract 0 or you can just leave it off. So F net equals 200 plus 70.7. We get 270.7. And we can say it goes east. Since it's a net force that we're working with, our units are newtons. Okay, so our free body diagram looks something like this. We have an eastward force pulling on it of 12. We have friction, which is 10. And if I want to label these, I could call them force pull if I want to. And this would be called what? Force of friction. Yeah, F sub F. Okay, I also have a gravitational force, F sub G. And what else would I have?
The normal.
Exactly. I'd have the normal because it's on a surface. Okay, we want to find net force. We know F sub G because it tells us it's 100. What do you think also equals 100? The normal. Okay, could you guys see that by yourself? Because the wagon's not moving up and down, right? The only thing that's pulling it is horizontal, so we're not lifting it up. It's just moving horizontal. So that means F sub n has to equal 100, which means those two cancel out. Okay? So our F net that we're looking at here is only horizontal. So we're going to take our F pull minus our F friction, which is 12 minus 10, which equals 2 newtons. To the left or to the right? To the right. We want to do the forces separately on this problem. So let's look at our force 1 right here. So we'll just call this F sub 1, and it's 40 newtons at 30 degrees east of north. So it's going to look, if I start here at an origin, it's going to look something like this. And I'm going to have my 30 degrees in here. Ooh, that's small. I know this one because I have to be east of north, which means I have to go north, and then east. So that way I can work backwards and say I went east of north. Okay. That's why the dotted lines go. So in order to get to my resultant, which is over here, I had to go north and then east, which means I work backwards and say it's east of north. Okay? So if you just think about it, like if I go north and then I move 30 degrees to the east, that's where I end up. I'm east of north. All right. So my hypotenuse here equals 40 newtons. And I want to solve for my components. So this top component is F sub 1 x, and this is F sub 1 y. Let's solve for these. So you guys solve components yourself, and then you tell me what we get for our values. Should either of these components be negative? No, because we're both going in the positive direction. We're going up and to the east. Okay, we got 20 for our x. Is that what everyone else got? Yeah. And what about our y?
34.6.
Okay. So our second force says we're going 30 newtons west. Easy, easy. So it just looks like this. Correct? 30 newtons west. So F sub 2 x equals what?
30,
Negative 30. Very good, because it's going west. F sub 2 y, 0. Perfect. Look how easy that one was. So easy. And let's look at our last vector here. We're going 50 newtons at 45 degrees west of south. So we're dealing with a 45-degree angle here. So we're going to go in this direction, and we can draw the triangle on either side because it's a 45-degree angle. That's the reason. If we want to go west of south, then that means if we want to follow its actual specifications, we go that way.
Wait, how do you figure that out?
Because west of south means we work backwards. So you go south and then west will give you a direction that is west of south. Okay. This says it was 50 newtons. So tell me the values for F sub 3x and F sub 3y. Okay, so we have 35.4 as both of our values, and they're both going to be negative because we're going in the negative directions for west and south. Very good. Why are the values the same? It's a 45-degree triangle. Very good. Very nice. Okay.
Wait, it's negative because it's going left.
Yes, it's going west.
Or going down.
West and down.
East, down, and down, bro.
All right. We want to find net horizontal force. So we need to be dealing with what components here?
F sub x. Oh.
All of the F sub x. So we're going to take F sub 1x, which is 20. We're going to add in our F sub 2x, which is negative 30. And we're going to add in our F sub 3x, which was negative 35.4. Sorry, my writing gets a little crowded there. Okay, so F sub x, you got what? Negative 45.4 newtons. So that means it's going 45.4 newtons in what direction? West or left. Very good.